Welcome to School of Civil Engineering. As we have started a STAAD Foundation Advanced Tutorial Series for beginner to advanced level, and in a previous video I've shown you that how we'll design and analyze a single or isolated footing by using easy method. Okay, so in this video I will show you about that how we'll design and analyze a combined footing with a very simple method. Okay, so let's start. And if you're new here, you can watch the previous video, and also if you think that this video or this channel is helpful for you, press the like button and also leave a comment so that I can understand that it's really helpful for you, and your that little effort inspire me for the future work. So let's start. First of all, I'll open STAAD Foundation software. If you are new to my channel, you can subscribe to my channel if you think that this is similar or helpful for you. It's taking some time. Okay, it's okay. So if you have followed my previous video, then you know that in this video I'll click here for new, then I'll click here Foundation Toolkit. So by using Foundation Toolkit, we'll do our work. Okay, this is the very easy method, but in a previous all video I have used a general foundation method, and in this video I'll show you about Foundation Toolkit. So let's start. Select that and click open. So after that, wait for some time. Okay, here press here at plus, then click here create isolated footing or block. After that, from here you have to select your cancel that. We'll use create combined footing, then click here. Then from here job name, you can change that job name according to requirement. Then design code, you can choose design code from here. Then unit, IS unit or English unit. I'm using English unit here. Then you can use according to requirement. Then code version, from here you can select your code version. I'm selecting that anymore. Then I'll click here next. Here you are seeing that concrete and river. So here we have to provide our value. If I see here, unit weight of concrete in pound per square feet, I mean pound per square feet, so it will be 155 as default, and you can change that according to your model. Then minimum bar spacing, what will be the minimum bar spacing? Suppose we consider our minimum bar spacing will be 4. Maximum bar spacing, it's showing 18 inch. Also you can change the data from here as required as your. So then from here maximum bar spacing, what will the maximum bar spacing? Suppose the maximum bar spacing will be 10. Okay, maximum bar spacing will be 10 inch. Then strength of concrete, suppose it's 2.5 KSI, or yield strength of steel, consider that it's 60 grade steel. And footing minimum bar size, what will be the minimum bar size of our footing minimum bar size? Suppose our minimum bar size will be 6. Okay, 6. Maximum bar size will be suppose 10. Then pedestal minimum bar size, it will be suppose 3, and maximum pedestal bar size, suppose it will be 7. You can change that according to requirement. Okay, you can change that according to requirement. So we have done our concrete and river properties. Then we have to click next. After that, we have to use give her data for pedestal geometry, cover, soil and safety. So here for our combined footing for our combined footing, here first of all we'll give here factor of safety against sliding. Suppose it's 1.5, you can increase that factor of safety against sliding. Suppose if we give here 2, then unit rate of soil, you have to give here unit rate of soil. You can change the unit from here. Then after that we'll go here. If we go here, depth of soil above footing, what will be the depth of soil above footing? Suppose it's 2.5 feet depth above footing. Okay, the soil bearing capacity, what is the soil bearing capacity? Suppose it's 3.5, consider that. Then surcharge charge for loading, what will be the surcharge charge? If available, you can provide here any surcharge charge. I mean surcharge charge the above soil, okay, soil weight, so you can give here. Then the bottom clear cover, what will be the bottom clear cover? Suppose it's 3 inch. Then depth of water table, what will be the depth of water table? So from here you can see that from our ground level to the depth of water table is from ground level to the water level. Okay, suppose it will be 20 feet. Okay, it will be 20 feet. Or you can give her anything according to requirement or according to data. Okay, then we have done that. Now here pedestal dimension, now we have to give her for pedestal dimension. So as in combined footing, there are two columns will work, and our pedestal number of pedestal also will be 2, so 1 and 2. Okay, so we can change here height unit, we can change there anything. Then width unit, width unit, and length unit. From here we can change our length unit. So I'm giving here everything in inch. After that, here if I give here our pedestal height, it's 4 feet, but I will give here suppose 2 feet, I mean 24 inch. Then 24 inch pedestal length, it will be 24 into 24, 24 into 24. Okay, it's done. 2 feet into 2 feet. After that, I'll press here next. Now we'll footing geometry. You are seeing here it's footing geometry. So first of all, we have to see here. Calculate dimension. What we'll do? We'll will calculate dimension or set dimension. If we click here, we have to give here the fixed value. Okay, set dimension. So I will use calculate dimension. After that, here if we see here fixed width is here FW means fixed width of the foundation. So if we select the fixed width, you can click here yes, and if you think no, then press here no. Then fixed over left overhanging, then you can select that. When you will select yes, then you have to give here value here, minimum left overhanging and maximum left overhanging. If you select fixed, it will used as fixed. And in our previous video I have shown you that here right overhanging length means the center point of the column to each of the foundation, in lateral direction, like that. Here given from that point to that point, and this is the center point of column to each of the foundation. Okay, after that we'll give here no. So column dimension, column distance, what will be the column distance? I mean one column to another column distance. CD means column distance, first column to second column. Suppose it will be 10 feet. Okay, consider it will be 10 feet or Yes, consider it will be 10 feet, so 120 inch. Okay, then width, WID, width of the footing. So what will be the width? You have to give here width. Okay, so what will be the width? Here, if we give here width, suppose it will be okay, 5 feet. Take it easy. And thickness, what will be the thickness? Here given 1 feet. Thickness are given 1 feet. Then here given maximum length. What will be the maximum length from that point to that point? What will be the maximum length? Here given maximum length will be 20 feet. Okay, maximum length will be 20 feet. And maximum width, maximum, this is width, thickness, it's showing the minimum. It's showing the minimum. What will be the minimum? Okay, so maximum length, what will be the maximum length? Suppose consider 20. Minimum width, consider it's 10. Okay, then maximum thickness, what will be the maximum thickness? 5 feet. Okay, done. Length increment 2, thickness increment 2, done. So, and here minimum left overhanging, minimum left overhanging. So what will be the distance, what will be the minimum distance from for that overhanging and that overhanging? Suppose we consider the minimum left overhanging will be consider it will be 1 feet, or consider it will be 2 feet. Okay, and it will be also 2 feet. Okay, so press here next. After that, force. Okay, force unit. So we have to provide force for first support and for second support. So for first support, I mean for first column and second column. Okay, for first column Fy, suppose it will be minus 150, and moment will be 30. Why Fy, Fx, Fz, Mx, Mz? Why it is? I have discussed about it many times. So we'll select from here dead load. So if you are new here, you can watch the previous video already given in description. Then for first support, we'll consider 1 to 5, sorry, minus 1 to 5 and 25. Okay, and we'll use it as live load. Then again we'll give for second support, suppose it will be 175 and MZ will be 35. It will be dead load. And for second support 150 30, it will be for live load. Okay, so we have done that, and also we can change the unit, force unit and moment unit from here according to requirement. That's not fact. Okay, then press next. After that we have to use load combination. So for that, select any code from here and click finish. So if you see that this is our combined footing. This is our combined footing. Okay, this is our first column and this is our second column. This first column, second column, and here is our combined footing. Okay, so we have done everything. Now we'll go for design and analysis. So we'll click here. Here you are seeing that calculation sheet is not available as design has failed. Design has failed. Okay, so again we have to, if we go here, error, unable to determine a suitable width for the given loading, because we have provided the maximum length of 10 feet. Okay, it is not suitable for our design. So we'll go here, edit, then go next, and concrete river. Okay, so pedestal geometry, we'll go for footing geometry. So here we'll increase the maximum width 15 feet and maximum length 25 feet. Then we'll press here next, and cancel. Again we'll go for design and analysis. Now you are seeing that our model are ready here. It's okay. So if we see from here, our left overhanging 5.667, or right overhanging 2.5, length, width, what is the length of our foundation? 18.167, width 10.667, and thickness 1.667. okay. Footing number 1, for footing number 1, the minimum is still 60. Minimum is still top. Here for top is still 14. Number 14 14 is still, and this number 6, 14 is still. Main is still. For bottom number 6, 7 is still. Secondary is still top, it's 23, 6 is still, and secondary is still. For bottom 23, 6 is still. So this software used number 6 bird everywhere, and this is 14, 17, 23, 23. okay. So if we see our model, so from here you can see that how what is the center to center distance will be for which types of bar and which direction. Here everything are available. So if we go here detail, for detail, so you can see here you can see here top bar will be 23 bar, number 6 23 bar, for bottom 23, 6, and also for top 14, and for bottom 17. And if you come here this is the thickness, and here is the, if we increase elevation view, this is the elevation view, and this is the footing plan, this is the plan view. okay, this is the plan view. So here you can also save drawing as AutoCAD file, and in this toolkit mode our schedule drawing is not available. For schedule drawing you have to design in, you have to design that footing in general mode. okay. So thank you very much, and if you think that was helpful for you, you can press the like button, and also leave a comment so that I can understand that was really helpful for you. And if you're a civil engineer, don't forget to press the subscribe button and also press the bell icon. Thank you very much. Stay connected till next video.